Hello students, hope you're all doing well. Welcome to another video by Quick Study. Today we will start another topic of GCSE Physics, and our topic for today would be work and power. So what is work? Work is done when a force causes an object to move in the direction of that force. We have a formula for that. The formula would be W is equal to F multiplied by D, where W is the work done and the unit is joules, and F is the force, which is the unit of Newton, and D is the displacement, and the unit for that is meters. Work is only done when the object moves in the direction of the force. If the force is perpendicular to the work done, then no work is done. Work is done only when the object moves in the same direction as the force. If the force is perpendicular to the displacement, then no work is done. Energy, on the other hand, is the ability to do work. We have to remember work done is equal to the energy transfers, as both of them are calculated in joules. Let's look at a problem we can solve with this formula. If a force of 10 Newton moves an object of 5 meters in the direction of the force, we have to calculate the work done. So W is equal to force multiplied by distance. So here the force is 10 Newton and the distance is 5 meters. So W is equal to 10 into 5. So the answer would be 50 joules. When we're talking about work and energy, we have to talk about the gravitational potential energy. So basically, gravitational potential energy is the energy an object possesses due to its position in a gravitational field. It is the energy stored in an object as a result of its height above the ground. We have a formula for this, which is GPE is equal to mgh, where GPE is the gravitational potential energy and m is the mass multiplied by the gravitational constant, which is 9.8 Newton per kg, and h is the height. Gravitational potential energy, or GPE, depends on 2 to 3 factors, which are the mass, the height, and the gravitational pull. The higher the object is positioned, or the more the mass is, the greater the GPE. For example, if we lift a book from the ground to a shelf, the Earth's gravitational field would basically pull it more, so it has more GPE. Let's look at an example we can do with this formula, which is we have to calculate the GPE of a 2 kg book placed on a shelf which is 3 meters high. So we know GPE is equal to m into g into h. So here GPE is equal to the mass, which is 2 kg, and we know that g is the gravitational constant, which is 9.8, multiplied by the height, which is 3 meters in this question. So the answer would come out as 58.8 joules. Along with GPE, there comes another energy, which is the kinetic energy. It is more common and may be known to us. So kinetic energy is the energy an object possesses due to its motion. Any object that is moving basically has kinetic energy. It also has a formula, which is Ke is equal to half mv squared. Here Ke is obviously the kinetic energy, and which is equal to half multiplied by the mass and velocity squared. So basically, kinetic energy depends on the mass of an object and how fast it is going. The more massive it is, the more kinetic energy it has, and the faster it is going, the more kinetic energy it has. For example, a car driving at a high speed has a lot of kinetic energy, which is why it takes a lot of more time to stop that car. Let's look at some examples we can do with this formula. Here, calculate the kinetic energy of a 1.5 kg ball moving at 4 meters per second. So this is a simple one. So we know kinetic energy is equal to half mv squared. So here, the mass is 1.5 kg and it is moving at 4 meters per second. So Ke is equal to half multiplied by 1.5 multiplied by 4 squared. The answer would be 12 joules. We must know that kinetic energy is equal to GPE, which basically means that half mv squared is equal to mgh. An example to understand this is given here. In a roller coaster ride, the truck falls through a height of 17 meters. We have to calculate the truck's speed at the bottom of this fall. Given that g is 10 Newton per kg, and if we assume that all the GPE of the truck at the top of the ride is transferred to Ke at the bottom, we can use the equation. So GPE is equal to Ke. which means mgh is equal to half mv square. The mass m of the truck appears on both sides of the equation, so we can cut it out. So then if we cut out the mass, the formula would be gh equal to half v square, which would be the gravitational constant multiplied by height is equal to half velocity square. So substituting h would be 17 meter and g is 10. So 17 multiplied by 10 Newton per kg would be is equal to half v square. So v square would equal to be 2 into 17 multiplied by 10 Newton per kg if we do the triangle method. And then as it is squared, we have to do a square root, which is v is equal to 2 multiplied by 17 multiplied by 10. So the answer would come out as 18.44 meter per second. So some of the GP of the truck had at the start would be transferred to heat and sound. As we know, it is not 100% efficient when energy is being transferred from one place to another. If this example was too difficult for you to understand, we can do a simple example to understand the relationship between GPE and KE. So in many cases, energy can be transferred between GPE and KE. For example, if we drop a ball from a particular height, so due to its height, it has GPE. Now, when we drop it, it's moving. So the GPE is basically converting into kinetic energy as it falls. And just before it hits the ground, all the GPE has been converted into kinetic energy. So that is how GPE is equal to kinetic energy. Last but not the least, we will be talking about power. So power is the rate at which work is done. Do not get it confused with energy. Energy is the ability to do any work, and power is the rate at which work is done. So it also has a formula, which is P is equal to W divided by T, where P is for power and W is for work and T is for time. We have to remember power measures how quickly the work is done. A higher power indicates the work is done in a shorter time. So let's look at an example we can do with this formula. If the work done is 50 joules in 10 seconds, let's calculate the power. So it's a very simple one. P is equal to W divided by T. So here work is 50 joules and the time is 10 seconds. So the answer would be P is equal to 50 divided by 10, which would be 5 watts. So power is calculated in watts. The unit of power is W, which is watts. That's all for today, students. Stay with us to learn more about physics and other courses as we post regularly on our channel. To learn more about our online tutoring service, do visit www.quickstudy.uk.